Welcome back, everyone. We're going to jump ahead to lesson 5 now of Unit 7. And this lesson, the purpose of this lesson is to give you an intro to something called the normal distribution. Some of you might know the normal distribution as the bell curve. It's called a bell curve because, as you can see here, it is bell-shaped. So these are kind of the characteristics you see of a normal distribution. As you can see, it's symmetric. Okay, because it's symmetric, we call it unimodal. Okay, unimodal means its graph has one high point, one clear high point. And notice that high point is in the middle. Okay, so it's symmetric and it's unimodal, has one high point. It's bell-shaped, which is why it's known as a bell curve. Okay, the x-axis is what we call a horizontal asymptote. So what that means is that the graph gets infinitely close to the x-axis but never actually touches the x-axis. Okay, the area between the x-axis and the curve is 1 or 100%. Okay, 1 or 100. So in other words, if I were basically to find the area of this blue shaded region here, it would be approximately equal to 1 or 100%. Okay, and what's unique about the normal distribution is that it's determined entirely by the mean, and we know that the mean is the average, and by something called the standard deviation. And the standard deviation is just a numerical measure of how spread out the data is from its mean. Okay, so that's called the standard deviation. So the normal distribution is determined by the mean and the standard deviation of the data. Okay, and lastly is this rule about the data here. So in a normal distribution, about 68%, which to give you an idea is a little bit more than 2/3. So about 2/3 or 68% of the data is going to be within one standard deviation of the mean or the average. 95% of the data is going to be within two standard deviations of the average. And then lastly, 99.7%, so almost 100% of the data is within three standard deviations of the mean. So these are all important characteristics of what we call the normal distribution or the bell curve. Okay, with that in mind, let's go ahead and take a look at the examples for this lesson. Okay, so these curves represent normal distributions with different means and standard deviations. What do you notice? So the first thing I want to call your attention to is, for example, this first one in the top left here. Notice it tells you that the mean is 10. And if I look at the high point is at 10. 10 is also in the middle. Okay, in the middle of the curve. Okay, the one next to it, it has a mean of 12, and when I take a look at that high point, notice that is also at the mean. In fact, every single one of these, the high point and middle of the bell is at the mean. Okay, that's an important thing about a normal distribution. So that's the first thing that I'm going to write, is that the mean is in the center of the bell curve. In other words, it's at the high point. Okay. The next thing I want to call your attention to is, notice, because a bell curve, because a normal distribution is symmetric, and we know that the mean is in the center, if it's symmetric, that means I can fold it over itself. So that means half the data is going to be larger than the average, roughly half the data, and roughly half the data is going to be less than the mean or less than the average. So because bell curves are symmetric, okay, about half or 50% of the data is larger than the mean, and about half or 50% of the data is smaller than the mean. Okay? So that's the second important thing I want you to notice. The third thing I want to look at is what happens to a curve when we have the same mean and different standard deviations. So for example, these two curves right here, okay, these two curves both have a mean of 10, but notice they have different standard deviations, okay? We could also, and I'll use a different color for this, we can also do the same thing with these two that I'm boxing in red. They both have means of 10 and different standard deviations, so on and so forth. Okay, so let's take a look. Actually, all three of these really have the same mean and different standard deviations. So let's look at what happens here. So what we're doing is we're going to compare these three bell curves because they have the same mean, but they have different standard deviations. So you'll notice that because all three have a mean of 10, okay, because they have a mean of 10, notice the center of the bell, the high point, are all at 10. So that does not change, okay? What does change is the height of the bell, okay? Notice the largest standard deviation in this case is 2. Notice the bell is lower and it's more spread out. When I lower it to 1, the center is still at 10, but it's more narrow and it's taller. And then if I further decrease the standard deviation to 0.8, it's again even more narrower and even taller. So when I have the same mean and the different standard deviations, the centers will be the same. The high points will be at the same spot. So the centers or high points will be the same. Okay, in the case that I have here, the high points are all at 10. Okay, the one with the smaller standard deviation, okay, will have a lower high point, and the bell part is more spread out. Okay, the one with the smaller standard deviation, okay, will have a higher high point, right? It'll be a taller bell. And the bell part will be narrower and less spread out. Okay? So the smaller the standard deviation, the taller the high point is, and the more narrow the bell part is. Okay? The last thing I want to look at is what happens. So this will be the fourth thing I want you to look at. What if I have the same standard deviation but different means? So the opposite of the last one. So what if I have the same standard deviation but different means? So for example, both of these have the same standard deviation of 1, okay, but their means are different. And the same thing can be said about these two right here, okay? They both have standard deviations of 2, but their means are the same, but their means are different. So let's take a look at these two first, okay? Notice, in this case, the high points are at different spots, okay? But notice the bells look exactly the same. They have the same height. They're spread out the same. The only difference is one has the high point at 10 and one has the high point at 12. So literally this one right here is the same as this one right here, except it's shifted over. It's shifted over to where the new mean is. And if we look at here, again, notice the bells look exactly the same. They have the same height. They're spread out the same. Okay, just this one is shifted to the left of this one, since this one only has a mean of 8. So that's what happens when you have the same standard deviation, different means. The bell parts look exactly the same. Okay, in other words, they have the same height. Okay. The only difference is that the high points are at different spots. Okay. In other words, one graph is shifted left or right. From the other graph. Okay. So they for all intensive purposes, the graphs look exactly the same, with the only difference being that one is just a shift left or right, depending on how different the mean is. Okay. That is it for today's lesson. Again, the purpose of this lesson was to just introduce you to the main ideas, the main characteristics of a normal distribution. We will go more in depth into how we use the normal distribution in the following lesson.